about a project titled A Big Data Mining Approach of PSO-based BP Neural Network for Financial Risk Management with IoT. Coming to the introduction part, in today's data-driven world, the financial sector is increasingly faced with the challenge of managing vast amounts of data generated by the Internet of Things, that is IoT. This data influx, coupled with the complexity and volatility of financial markets, necessitates innovative and efficient risk management solutions. In this context, we propose a cutting-edge approach that harnesses the power of big data mining and the integration of particle swarm optimization, that is PSO, and backpropagation, that is BP neural network algorithms to tackle financial risk management challenges in the IoT era. So our main objective for this project is effective financial risk management. That is, the primary goal is to enhance financial risk management capabilities by utilizing advanced data mining techniques to process and analyze vast amounts of financial and economic data generated by IoT devices. Accurate risk prediction. The proposed approach aims to improve the accuracy of risk predictions by integrating the PSO with BP neural network, allowing for more precise and reliable risk assessment. Real-time risk assessment. The system aims to provide real-time risk assessment, enabling financial institutions to respond promptly to emerging risks and immediately timely risk management strategies. Scalability and adaptability. The approach seeks to be scalable and adaptable, capable of handling various financial domains and accommodating changes in the dynamic financial landscape and IoT data sources. Reduced false positive and false negative. By achieving these objectives, the big data mining approach of PSO-based BP neural network for financial risk management with IoT seeks to revolutionize financial risk management in the IoT era, empowering institutions to navigate the complexities of modern financial markets with greater confidence and resilience. Now coming to the requirements part, we have two types of requirements, that are hardware requirement and software requirement. Hardware requirements, that is operating system Windows only. Processor i5 and above is required. Minimum 4 GB of RAM is required. Hard disk 20 GB and above. Coming to the software requirement, Python IDEL, that is 3.7 version is required. Now coming to the methodology part, first we have upload balance sheet dataset. In this step, you will need to upload a dataset containing balance sheet data. The balance sheet data is a financial statement that provides a snapshot of a company's financial position at a specific point in time, including its assets, liabilities, and shareholders' equity. The dataset should be in a structured format, that is .csv file. Second, generate, train and test model. Before you can build a predictive model, you need to split your dataset into two sets, the training set and the testing set. The training set is used to train the machine learning model, while the testing set is used to evaluate the model's performance and test its predictions on new or unseen data. A common split ratio is 80% for training and 20% for testing, but this can vary depending on the size of your dataset and the problem you are trying to solve. Third, run PSO-BP neural network algorithm. PSO-BP stands for particle swarm optimization with backpropagation. It is an optimization technique commonly used for training neural networks. The PSO part helps to optimize the weights and biases of the neural network to find the optimal values that minimize the error or loss function. The BP, that is backpropagation part, involves calculating the gradients of the error with respect to the network's parameters, which is used to update the weights and biases during training. When you run the PSO BP algorithm, it optimizes the neural network's parameters based on the training data, fine-tuning them to improve the model's performance and ability to make accurate predictions. Fourth, upload test data and predict decision. After training the model using the PSO BP algorithm, you will need to upload the test data set that was set aside earlier. The test data set contains data that the model has not seen during training, simulating real-world scenarios where the model needs to make predictions on new unseen data. Fifth, comparison graph. To assess the performance of the model, you can create a comparison graph. This graph visually shows the model's predictions against the actual values or ground truth from the test data set. Depending on the nature of your prediction task, you might use different metrics for comparison, such as accuracy, precision, recall, or mean squared error, among others. The comparison graph allows you to see how well the model is performing and whether there are any patterns of overfitting or underfitting. Overfitting occurs when the model performs well on the training data but poorly on new data, while underfitting occurs when the model performs poorly on both training and test data. By analyzing the comparison graph, you can gain insight into the model's strengths and weaknesses, make necessary adjustments, and assess its suitability for the intended task. Now coming to the execution part for this project. To execute the project, first we need to open the code folder. Here we have PyCatch folder. In this we have two Python files, where these two Python files are containing the Python scripts in it. This dataset folder containing the training dataset and the testing dataset. So here training dataset is the .csv file and testing dataset is the .txt file. Here BP neural network PSO and PSO BP are the Python files which are containing the Python scripts in it. Here BP neural network is the main code of the file. This is the run.bat file. Instead of executing the program in command line interface, we created Windows bat file to execute the project. Now to run the project, double click on run.bat to execute the project. This is the graphical user interface. With this, we are interacting with the program. Now click on Upload Balance Sheet Dataset and click on Dataset, which is .csv file. Click on Open. Now click on Generate Train and Test Model button to read dataset and then convert all dataset into numeric values to allow PSO to optimize features and then build BP network. Here we can see dataset loaded over here. Now click on PSO BP neural network algorithm to optimize features and to build BP network. Here we can see the entire dataset to numeric values and then apply PSO, and we can see from each row PSO choose only 5 attributes and 11 attributes and then generate a model. Now click on Upload Test Data and Predict Decision button to upload a new test data, which is the .txt file, to predict decision as positive or negative. Here we can see for each new records status predicted as positive or negative. Now click on Comparison Graph. Here x-axis represents the positive and negative samples, whereas y-axis represents count. So here now we close this project. Now coming to the conclusion part. In summary, the A big data mining approach of PSO-based BP neural network for financial risk management with IoT addresses the complexities of modern financial markets and IoT-generated data by providing an efficient and accurate risk management system. By embracing this innovative approach, financial institutions can effectively navigate risk, make better informed decisions, and safeguard their financial health in a dynamic and data-rich landscape of the IoT era. The key findings and implications of these approaches are enhanced accuracy and efficiency. By combining PSO with BP neural network, the approach achieves improved accuracy in risk prediction, real-time risk assessment with the ability to process and analyze vast amounts of IoT-generated data in real time. The proposed approach empowers financial institutions to promptly detect and respond to emerging risks. Data-driven decision-making, leveraging big data mining and advanced algorithm provides financial institutions with data-driven insights to support decision-making processes. Competitive advantage, institutions that adopt this approach gain a competitive edge in the market.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.